All right, now let's dive into the fundamentals of API security testing. Understanding these fundamentals will act as a foundation for the rest of our course. API, or Application Programming Interface, includes a set of rules and protocols for building and interacting with software applications. In today's tech driven world, APIs act as the backbone of many services, effectively allowing different software programs to communicate with each other. However, as with anything tech related, security is paramount, and APIs are no exception. Now, when we talk about API security, we refer to the practices and protocols put in place to protect APIs from misuse, malicious attacks, or even flaws in their design that could lead to unauthorized access or data breach. API security testing, therefore, is a crucial part of maintaining the integrity and safety of APIs. It involves assessing the security of APIs, identifying vulnerabilities, and ensuring that it can handle unexpected or malicious input or behavior. In the upcoming sections of this course, we will delve deeper into how to understand the potential security issues in APIs, learn about various tools designed to enhance API security, and practice API security testing, which will give you hands-on experience. You will also get a solid understanding of HTTP methods and how they play an important role in API security. Please note that having foundational knowledge of APIs and HTTP methods can be beneficial, but don't worry if you are new to this area. We're going to cover everything you need to get started with API security testing. Now that I've outlined what API security testing entails, let's continue with our journey. In this course, we are focusing on several key objectives to increase your effectiveness in securing APIs. These objectives are outlined on this slide and will provide a base for what to expect from the course. Our first objective is to develop a deep understanding of APIs and the unique security challenges they present. In any interconnected system, security is a paramount concern, and APIs are no different. We aim to take you beyond a superficial knowledge of APIs to understand how they may become vulnerable and what steps can be taken to secure them. Secondly, we will explore various API security tools which will aid in your security testing efforts. These tools can facilitate the detection, prevention, and management of security risks in APIs, making them an essential resource in any security tester's toolkit. Our third objective is not just about knowledge, but about its application. You will get to practice API security testing, helping you to apply the theoretical understanding you'll gain our discussions. This practical application is essential for truly mastering the subject. Finally, we will spend some time learning about HTTP methods. These are foundational to how APIs work and, by extension, their security. Through a clear understanding of HTTP methods, we'll be able to identify potential vulnerabilities and implement effective security measures. By achieving these objectives, you will equip yourself with the necessary knowledge and skills to effectively secure APIs. Whether you're a developer, a security tester, or an IT professional, these objectives will guide our journey throughout the course. All right, let's now delve into the concept of API, which stands for Application Programming Interface. Now, that might sound highly technical, but in simpler terms, an API acts as a bridge that lets two different software engage in a meaningful dialogue. Picture yourself working on a program. Wouldn't it be highly convenient if you have all the necessary building blocks provided to you? That's exactly what a good API does. It simplifies the process of development by providing all the essential elements you need. APIs hold immense importance, particularly in programming graphical user interface or GUI components. For those unfamiliar with the term GUI components, they are the elements that enable users to interact with digital platforms, be it buttons you click on a web page or swipe actions on your mobile screen. In a nutshell, the role of an API is to provide a channel of communication between software and to simplify the process of program development by acting as a helpful toolkit of essential software interaction methods. Here on this slide, we see a strong emphasis on understanding the crucial role APIs play. And as we progress through the course, we'll delve more deeply into it, recognizing not only how APIs function, but also how to make the most of them while programming. Moving forward in our discussion about APIs, let's now delve into the sphere of API security. Even though APIs are a great tool for enabling software communication, the aspect of security can never be overlooked. APIs in a system are not exempt from potential security threats and vulnerabilities. So, what are the common API security risks we need to be aware of? The first on the list is injection. This risk involves malicious data being inserted or injected into the API to execute unintended commands or to access unauthorized data. This can take the shape of SQL, NoSQL, or command injection. Next up, we have broken authentication. Broken authentication relates to flaws in the authentication or session management functions. An attacker could potentially exploit these vulnerabilities to impersonate another user, steal their data, or even manipulate their user privileges. Common examples of this can be password, keys, or session tokens compromise. Finally, we have sensitive data exposure. As APIs facilitate interaction between software, sometimes they might inadvertently reveal sensitive data. For example, financial information or personally identifiable information might be exposed if not properly protected. Thus, understanding these key security risks is vital while working with APIs, so that we can build robust systems keeping this in mind and taking necessary precautions. Understanding API safety and employing necessary measures should be a top priority to ensure the secure operation of systems and data protection. On this slide, we're delving into the realm of API security tools. Ensuring the security of any API is crucial, and thankfully, there are some popular API testing tools to assist us in ensuring this security. First up is Postman. This fantastic tool offers a user-friendly interface that simplifies the process of constructing requests and reading responses. It makes it easier to spot any failings in your API's data protection or any discrepancies in the responses to thwart security breaches. Next is SOAP UI. With SOAP UI, you can effortlessly test REST and SOAP APIs as well as web services. This tool is essential for any API security toolbox, as comprehensive testing is one of the first steps in keeping your APIs secure. For a more dynamic approach to application security testing, we have OWASP ZAP. This tool is excellent for identifying vulnerabilities in your APIs before they can be exploited, adding an extra layer of protection to your API environment. Lastly, but not least, we have curl. Though it's a command line tool, curl is unparalleled when it comes to making HTTP requests. With CURL, you can quickly and efficiently create requests to test the integrity and security of your APIs. While each of these tools has its strengths, they all play a crucial part in ensuring that your APIs remain secure. By using them effectively, you can reinforce your API defenses and evade the common security risks that APIs face. Remember, the more secure your APIs are, the more reliable and trustworthy your applications will be. Let's delve a bit deeper into one of the popular API testing tools we've previously mentioned, specifically Postman. Postman has gained popularity due to its user-friendly interface, and it is an excellent tool for constructing, sending, and importantly, testing APIs. So how does Postman contribute to efficient API testing? Well, the first outstanding feature is that Postman allows users to construct intricate HTTP requests swiftly. Let's have a look at an example of such a request. It's a command for a new user creation in JSON format via a POST method. The advantage here is the immediacy with which we can create and send these requests, saving developers a lot of time. Not only does Postman translate to faster request creation, but it also allows users to examine the responses to these requests with ease. This is particularly important when testing APIs, as it lets developers dig into and accurately understand server responses. As you can notice, responses can be read comfortably, enabling swift identification and rectification of any issues. Therefore, Postman stands out as an API testing tool due to its features that provide quick construction of HTTP requests and thereafter easy interpretation of the responses received. It offers a complete testing environment where developers have all the necessary toolkits to conduct thorough and swift API testing. In this slide, we're focusing on the use of SOAP UI for API testing. This is a powerful tool that shines in two main features. Feature 1 highlights how it allows for simple and quick testing of both SOAP and REST APIs. Let's look into that further. SOAP and REST are two different types of web service communication protocols. SOAP usability to efficiently test both is exemplary. Now you may wonder, how do we perform the testing? The command given here provides an example of how a SOAP request would look like. It's structured as a SOAP envelope that has a SOAP header and a SOAP body. In this case, we're looking into a temperature conversion request from Celsius to Fahrenheit. Inside this envelope, we have the web temperature convert element, which is where we input our actual data, in this case, 100 Celsius. Looking at our second feature, SOAPUI offers a high level of customization for each request. This implies that you have the freedom to customize your requests to suit your specific requirements. Whether it's modifying the headers or changing the request's body content, it's all made possible with SOAPUI. This level of customization makes this tool quite versatile for diverse API testing needs. In essence, SOAPUI provides an easy way to test both SOAP and REST APIs, coupled with an extensive level of customization that fosters a user-oriented approach to API testing. We will now continue with our course presentation. In this slide, we delve into API security testing, specifically focusing on various HTTP methods. This is a crucial aspect of API testing. Why? Because the HTTP methods indicate the intended action to be taken. HTTP methods essentially serve as the verbs within commands that prescribe the necessary action. Think of them as the drivers behind each API call. Some of the most commonly used ones are post, get, put, and delete. While each of these HTTP methods has unique semantics, they also share some common features enclosed within a particular group. Now let's look at what they're used for. Post, typically used to send data to the server. Get, which we'll examine in detail in our next slide, is deployed to fetch data from a specific resource. Put, frequently employed to update data. Delete, as the name indicates, it's used to delete data from the server. From the outlined universality of these HTTP methods, it's clear how they directly impact the overall behavior of API interactions. Hence, they form an integral part of security testing in API management. It is essential to understand these methods and their implications to correctly use them in function calls, ensuring effective communication with the server and secure data handling. In the next slides, we will take a deeper look into each of these HTTP methods, starting with GET. We'll explore their syntax, common usage, and best practices, shedding light on how to ensure secure, effective, and efficient API interactions. Continuing along with our exploration of API security testing, let's focus on the GET method now. The GET method is primarily used to retrieve data from a specified resource. It's one of the HTTP methods we use when communicating with an API. Let's go over an example of how you might use the GET method. Suppose we want to retrieve data about users, so the command could look like this: curl-x get example.com/API/user. Under normal circumstances, the response from this request would be data about all users from the specified resource. Keep in mind, though, as a best practice, the GET method should never be used to transmit sensitive data, because this data would be included in the URL. As URLs can be cached or stored in logs, this could potentially expose sensitive data to unauthorized users. So if you're calling an API that requires sensitive data, like a social security number or bank account number, HTTP methods like POST or PUT might be more appropriate. As a rule of thumb, remember to avoid keeping sensitive data in the URL when using the GET method. This is a critical aspect of API security. Now, let's shift our focus to API security testing with the POST method. POST, which stands for Power on Self-Test, is primarily leveraged to send data to a server with the purpose of creating or updating a resource. Let's break down a command example to understand how it operates. If you input curl-x post d password equals user /example.com/API/user into your chosen interface, what you're essentially doing is sending a request to the specified server to create or update a user resource. Alongside this request, you're also supplying the server with data, in this case, a login and password, to provide specificity to the creation or update. In response to this command, you will typically receive a confirmation of user creation. This acknowledgement helps in monitoring the success of your activity, and it ensures that your command has correctly run its intended course. As we handle sensitive information, it is vital to implement best practices at each step of the process. For the POST method, you need to validate input and sanitize it. Remember, the data you're sharing is subject to security threats and can possibly be manipulated. Therefore, it is crucial to avoid injections and implement a thorough check before broadcasting any information. By adopting these practices, you bolster the security of API endpoints and guard against unauthorized or malicious alterations to your data. This approach to API security testing will enable us to efficiently and effectively manage and manipulate resources on a given server. Let's wrap up this segment with some final thoughts on API security testing. We covered understanding basic API protocols. These are rules or standards that determine how our API communicates with other software. They are key to creating a successful API, and it's essential that we understand them. We went through the exploration of different HTTP methods. This has shown us the various ways we can interact with our API. For example, we learned about the POST method, which is used to send data to a server to create or update a resource. We've also introduced some testing tools like Postman and SoapUI. These are incredibly useful for automating and simplifying your API tests. Both of them have their own unique strengths, which means you can pick the one that best suits your needs. Furthermore, we practiced API security testing with different commands. This is a crucial step in ensuring your API is secure and functions as expected. Always remember, the goal of API security testing is not just to find vulnerabilities, but to fix them. And finally, stay safe while checking the API endpoints. Sanitize and validate input to avoid injections. Always prioritize security in your API development and testing processes. You can refer to the following tools for further research and guidance. Postman, which can be found at postman.com, and SoapUI at soapui.org. As we progress, remember that practice makes perfect. The more you test, the more familiar you'll get with the process, and the better you'll become at spotting potential vulnerabilities.